Hello. Today the digital electronics logic gates. So logic gates. So logic is nothing but in digital. In my previous video we discussed it is in terms of zeros and ones only. That means high level or low level, or it's a true or false. That is nothing but 0 and 1. That is the digital logic. And next is the gates. Gate, use the general term. Gate is being used to open and close, like any gate is there, a railway gate is there, or for any building gate is there. The purpose of this gate is to allow. So it is only in two states, it is open or closed. Neither open nor closed state is not there. Like this, neither 0 nor 1 state, intermediate state is not there. It may be 0 or it may be 1. So means what? If we connect one LED or bulb to the output, if one output, it will make the output LED on or bulb on, and output is 0, it will make output LED or bulb off. So that is nothing but the gate. So logic gates are there. We shall see now the basic gates. So next is, these are the basic gates. In digital electronics, any kind of circuit one can build using these gates. First three are the basic, that is, one is AND gate, another is the OR gate, and the NOT gate. So the next remaining gates are being driven from the existing these three. If we add the NOT gate to the output of this gate, then it becomes NOR gate. If we add NOT gate at the output of AND gate, it becomes NAND gate. Likewise, XOR gate is there and XNOR gate is there. So the basic three gates are there. So we shall see how it works each gate one by one. So this first gate is AND gate. In digital electronics, for any kind of circuit, any kind of design, three things are there. The first one is the logic symbol. So this is the logical representation of the AND gate, and it is actually series connection. The second thing consists, first thing is logic symbol, I told you. Second thing is the truth table. That means how the particular gate works. It's a functionality. And the last thing, it's an equation. One can say it is a expression. So if we go for its truth table, so this is the symbol. This is the symbol of AND gate. Then truth table, as I told you how it works, it gives its a functionality. So I'll give here for this AND gate A as the one input and second B input, and output is Y. So here as 2 raised to 2 power, that means 2 raised to 2 power is nothing but it comes to be 4 combinations. So in truth table we will get the 4 combinations. I'll take the first input A, then second input B, and last one is the output Y. So one can say these are the inputs, A, B are the inputs, and Y is the output. We shall see the combination, 4 combinations. The first combination is 0 0. What would be the output? Then second one is 0 1. The third one is 1 0, and fourth one is 1 1. As I said, if we go for its circuit diagram, if I connect here the power supply plus 5 volt, this is plus and this one is the minus, and it's a 5 volt. Then the 2 series connections are there, switches are there, and here if we connect LED over here, or one can say bulb over here, so this is the switch S1 and this is the switch S2, and this is, one can say, bulb, and this is the battery, 5 volt battery as a supply connected. As if we give 0 0, that means if we go for the first combination, if I apply here 0 and here 0, what will happen? Both the switches will remain in off state. They are remain in open circuit. So this LED will not become on. That means the output is 0. So here again it is 0. Output is 0. The next combination is 0 1. Here if I apply 0 and here 1. So what will happen because of this application of the input combination? This switch gets closed, but first switch remains open. So again, in this case also, this LED will remain off. Here I'll get the output as a again 0. Now next is third condition I'll apply, that is 1 0. So 1 and the next one is the 0. This is 1 and this is 0 combination. So in this case, the S1 switch gets closed, still S2 gate remains open. So in this case also, the output is 0, that means bulb will not become on. So here the output is 0. Next, the last combination is 1 and 1. In this case, as both the inputs are 1, both the switches gets closed, that is S1 switch as well as S2 switch. As a result, the output is what? 1, that means this bulb becomes on. So here I'll get the output 1. So in this case, in this way, one can say if any one of the input is 0, output of AND gate is 0, and if both the inputs are 1, then and then only output of the AND gate is 1. So the logical expression for this AND gate is A dot B. So this is AND gate. So in this case, the switches are connected in series. So this is the functionality of AND gate. Now we shall see the next one gate, that is OR gate. So in this case also, we'll apply the input A input, second input is B, and output is Y. Here the expression is A plus B. Then the truth table of the OR gate is like this, that is again A input, B input, and Y is the output, right? As here also, as two inputs are there, likewise in case of AND gate, here also 4 combinations are there, 0 0, next is 0 1, third is 1 0, and fourth is 1 1. So here, this as far as these inputs are concerned, the switches are connected in parallel. So the here for OR gate, the circuit diagram is like this. 5 volt power supply is there as a battery, and then this bulb is there. And these switches are connected in shunt, S1 switch, and this is S2 switch. If we apply first combination of this truth table, that is 0 0, here 0, here 0, what will be the result? Both the switches, that is S1 and S2, will remain in off state. If both the switches are remain in off state, that means there is no path to pass the current from positive terminal to the negative. So this LED will remain off. So means what? The output of this OR gate is 0. Right. Now we'll go for the second condition, that is this one, that is 0 1. Because of this 0, this switch is open circuit, but S2 gets closed. S2 switch gets closed, and there is a path plus terminal through this bulb, through this S2 switch to the negative. Cycle completes, and in this case the LED or bulb, rather one can say, remains on. This LED will become on. So as a result, if bulb is on, means output is 1. Next thing, third combination, we shall see the third combination. So in third combination, this 1 0 combination is there, S2 switch is there, and here S1 switch is there, 1 and S2 is 0. As a result, this S1 switch gets closed, S2 remains open. As this connection is in shunt or in parallel, one can say, either of the switches remain on, the current pass from one end to the another end. So here from this, through this bulb, through this S1 switch, it gets passed to the negative terminal. So LED remains on in this case also. Here output is 1. Now we shall see the next combination, that is if both the inputs are 1, what happens? So if S1 and S2 inputs are 1, both the switches gets closed. S1 and S2 switches gets closed. That's why via S1 and S2 current gets passed towards this negative terminal. In this case also LED will become on, and as a result the output is 1. So this is the second gate, and what it gives indication, any one of the input it remains 1, output remains 1. But this is not the case in the previous gate, that was in the AND gate. So in case of AND gate, any one of the input is 0, output remains 0. If both the inputs are 1, then and then only output remains 1. But in case of OR gate, if any one of the input is 1, output remains 1. So depending upon the requirement, one can use these gates. So this is nothing but the OR gate. And out of these 3 basic gates, up till now we covered second one. We shall see the third one, and the third one is the NOT gate. The title of this symbol is the NOT gate, and NOT gate is nothing but the complement. Complement, that means if previous logic is 1, then you will get next logic as a 0. So always it complements. The truth table of this is the logic symbol. Logic symbol of NOT gate. The truth table is like of NOT gate is like this. It is having one input and only one output, that is Y. So here the A input is there, only one input, and output is Y only. So as I told earlier, 2:1, in this case 2:1 comes to be only 2 combinations of input are possible, and these are 0 and 1. In previous case, as 2:2 was there, so that's why the value was coming 4 and the combinations were 4. But in this case the combinations are 2, as only one input is there. So this is number of inputs. Number of inputs, how many number of inputs are there? So for this, the circuit diagram is like this. So here the transistor is there, then input is there, and this is output is there. So here output, one can say here plus VCC. This resistor is called as RC, then this is RB, this is Q transistor. The transistor is Q. Here one can apply the input. Input is being applied. So we know the property of this transistor. This is NPN transistor. So the functionality of NPN transistor is, if input is 1 and output is, what is the output, we shall check now. If input is 0 and input is 1, the transistor becomes off, and if input is 1, the transistor remains on, as it is a NPN transistor. Because of this, what happens, if I draw the equivalent diagram of this, so it looks like this. This is a switch, here ground, then through this resistor input is applied. This is RB, this is input RC, output is taken from this terminal, here Y is there and here plus VCC is applied. So if we check the equivalent diagram of this is nothing but transistor is nothing but the switch. So as far as this input is concerned, this is A input. If its value is 0, what happens? As I said, if its value is 0, this transistor remains off, the switch gets open. So there is no path to pass this current towards the ground. So I'll get output Y is 1. Why it is 1? Because it is being connected to VCC. Actually this 1 is nothing but the VCC. In this way, if I apply the input 0, I'll get output 1. As I said, it is a complement of the input. In the next case, if I apply the input as a 1, if this is 1, what will happen? If input is 1, transistor becomes on. Transistor becomes on means it gets closed. Switch gets closed. And in this way, there is a path to flow the current from VCC to ground. In this way, the output terminal is connected to ground and I'll get output is equal to 0 as output is connected to ground. So here I'll get the output as a 0. So in this way, I'll get the complement of input. If 0 is the input, I'll get 1 output. If 1 is the input, I'll get output is equal to 0. That means simply in case of NOT gate, output is complement of the input. In this way, one can represent the NOT gate. Thank you.